Welcome back, students. This is the session 33 from the playlist of NEET Physics Part 1. The chapter is Work, Power and Energy, and the topic for this session is angular momentum. I have taken this question, which is written on this board, from the CBSE All India Pre-Medical Test exam, and this question was asked in the year 2015. So the question here is a mass m moves in a circle on a smooth horizontal plane with a velocity v naught in a radius of r naught. The mass is attached to a string which passes through a smooth hole in the plane as shown in this figure. The tension in the string is gradually increased and the mass starts moving in a circle of radius r naught divided by 2. So the final value of the kinetic energy is, so there are four options here and we have to find the correct one. So in this question, we will be utilizing the concept of law of conservation of angular momentum. Law of conservation of momentum. The law of conservation of angular momentum says that is the angular momentum of a rotating body always remains conserved. That is, the initial angular momentum should be equal to the angular momentum of this body when it is rotating in a radius of r naught divided by 2. That is, the angular momentum of this body when it is rotating in a circle of radius r naught should be equal to the angular momentum of this body when it is rotating in the radius of r naught divided by 2. So, what is the initial angular momentum? Now, angular momentum is basically the moment of linear momentum. This is the definition of angular momentum. Moment of linear momentum. Now, what is the linear momentum? Linear momentum is mass into velocity. So, this will be equal to m v naught. And what is the meaning of moment of linear momentum? That is, moment of linear momentum is basically the product of this linear momentum and the perpendicular distance of this object from the axis of rotation. So, in this case, it will be equal to r naught. So, this is the initial angular momentum. What will be the final angular momentum? This will be equal to m. Now, when the tension in the string is increased gradually, this body of mass m it starts moving in a circle of radius r naught by 2. So in this case, what will happen? The velocity of this object of mass m will also change, so that the final angular momentum and the initial angular momentum remains conserved. So this will be equal. Now let us consider that the velocity of this body of mass m when it is moving in the radius of r naught by 2 is vf. So the linear momentum will be equal to m into vf and the angular momentum will be the linear moment of the linear momentum, which will be equal to m vf into r naught divided by 2, because moment of linear momentum is the product of the linear momentum multiplied by the perpendicular distance of that object from the axis of rotation. Axis of rotation, or you can say from this point of rotation. So now what I will be doing is, I will be simply equating the initial angular momentum and the final angular momentum and try to find the value of Vf. So the initial angular momentum is equal to m v naught r naught, and the final angular momentum is equal to m, this is n. Then the final angular momentum is equal to m vf into r naught divided by 2. So here this m will get cancelled out, r naught will get cancelled out, and finally the velocity of this object of mass m when it is rotating in the radius of r naught by 2 will be equal to 2 times of v naught. So the final value of kinetic energy, will be equal to half into m, because the kinetic energy is equal to half mv square. So half into m, and now v is what? The velocity of this object when it is rotating in a circular path of radius r naught by 2. This will be equal to m. This will be equal to 2 v naught whole square. This is the velocity of the object when it is rotating in the circle of radius r naught by 2. So this is equal to 1 by 2 into m into 4 v naught square, or we can say that the final value of the kinetic energy will be equal to 2 times m v naught square. So here the correct answer is the C. That is this is the third option. That is C. This is the correct option. And so in this question, we are supposed to utilize the concept of law of conservation of angular momentum. And using the law of conservation of angular momentum, we have calculated the velocity of this object of mass m when it was moving in a circle of radius r naught divided by 2. So, and after finding the velocity of that object when it is moving in a circle of radius r naught by 2, we were able to find the final value of kinetic energy using the formula for the kinetic energy, which is half mv square. So thank you very much for joining this session, and in the next session I will be continuing with the same chapter, that is work, power and energy, but I will be coming up with a different type of a question which will be based on a different concept. So till then, have a nice day. Bye.